Hi, this is javinkhrod, a chemical engineer by profession, going to continue our today's topic, thermosyphon. Now, first question arises, what is thermosyphon? Thermosyphon is a method of passive heat exchange based on natural convection which circulate a fluid without a necessity of mechanical pump. Thermosiphoning used for circulating of liquid and volatile gases in heating and cooling applications such as heat pump, water heater, boiler, furnace. Thermosiphoning also occur across air temperature gradient such as the utilized wood, fire chimney and solar chimney. Now circulation can either be open loop as well as substance in a holding tank pass direction heated transfer, the tube mounted on bottom of tank, the distribution point, even one mounted above original tank, or it can vertical closed loop circuit with return the original container. It purpose to simplify transfer of liquid or gas while avoiding cost and complexity convection pump. Now simple thermosyphon. Natural convection of the liquid start when heat transferred, the liquid give rise to a temperature differences from one side of loop to the other. The phenomena, the thermal expansion means the temperature differences will have corresponding difference density across the loop. The warmer fluid on one side of loop less dense and thus more buoyant than cooler fluid on the other side. The warmer fluid will float above the cooler fluid. The cooler fluid will sink below the warmer fluid. The phenomena, natural convection, known by the saying heat rises, convection moves the heated liquid upward in the system as it simultaneously replaces cooler liquid returned by gravity. A good thermosyphon has very little hydraulic resistance so that liquid can flow easily under relatively low pressure produced by natural convection. Heat pipe. In some of situations, the flow of liquid may be reduced further. To stop, perhaps the loop is not entirely full of liquid. In case the system no longer convex, it is usual thermosyphon. Heat can be still transferred in the system by evaporation and condensation of vapor. However, system is properly classified as heat pipe thermosyphon. If the system also contains other fluid such as air, then heat flux density will be less than heat pipe which contain only a single substance. The thermosyphon has been sometimes incorrectly described as gravity return heat pipe. Heat pipe usually have weak return, the condense, the evaporation via capillary action. A wick is not needed thermosyphon because gravity moves the liquid. The wick allows heat pipe to transfer heat. There is no gravity which is useful space thermosyphon simpler when heat pipe. A single phase thermosyphon only transfer heat upward or away from the acceleration vector. The orientation is much more important thermosyphon than heat pipe. Also thermosyphon can fail because bubble in the loop requires circulating loop of the pipe. Reboil. The piping thermosyphon resists flow. The excessive heat is applied. The liquid may boil. Since gas is more buoyant than the liquid, the convective pressure is greater. There are well-known inventions called a reboiler. A group of reboiler attached to a pair of plana is called calendaria. In the sum of the circumstances, the boiling of the fluid will be cause system to stop working. The volume of steam created displaces too much the water and circulation stop. The term phase change thermosyphon is a misnomer, should be avoided. The phase change occur thermosyphon means that the system either does not have enough fluid or it is too small to transfer all the heat convection alone. Improve the performance, either more fluid is needed, possibly larger thermosyphon. All other fluid should be pumped out the loop. Now, solar energy. The solar heating system, future thermosyphon. Thermosyphon are used Some of liquid-based solar heating system heat a liquid such as water. Water is heated passively by solar energy and relies on heat energy being transferred from sun to a solar collector. The heat from collector can be transferred to water into two ways: directly, where water circulates through collector; indirectly, where an antifreeze solution carry heat from the collector transfer it to water tank via heat exchanger. The convection allows for a movement heated liquid out of the solar collector to be replaced by colder liquid, which is turn heated due to the principle it is necessary water to be stored tank above the collector. Uses: with proper cooling, a modern processor chip can rapidly reach temperature that causes malfunction. Even common heat sink and attach a typical processor operating temperature may be still reach 70 degrees centigrade. A thermosyphon can efficiently transfer heat over a much wider temperature range and typically maintain the process temperature 10 to 20 degrees centigrade cooler than traditional heat sink and fan. In some of cases, it is also possible the thermosyphon may cover multiple heat sources and design wise most compact than an appropriate size conventional heat sink and fan. Now drawback: thermosyphon must be mounted such that vapor rises up and liquid flow down the boiler with no band and tubing for liquid to cool. Also thermosyphon fan that cool the gas need cool air to operate the system has completely airtight and no process of the thermosyphon will not take effect that causes the water to only evaporate over small period of time. Now engine. Some of early motor vehicle and engine powered farm and industrial equipment use thermosyphon circulation, move cooling water between the cylindrical block and radiator. The method water circulation depend keeping enough cool air move past the radiator to provide sufficient temperature differential. The air movement was accomplished forward motion vehicle and use of fan. The engine power increases flow of water was required, so engine driven pump were added. The assist circulation more compact engine began. The smaller radiator require more convoluted flow pattern so that the water circulation become entirely dependent on the pump and might even reverse against the natural direction. An engine that circulates cooling water only by thermosyphon susceptible overheating during prolonged period of idealizing a very slow travel since lack of forward motion provide too little airflow past radiator unless one or more fans are able to move enough air themselves. Thermosyphon systems are also very sensitive, low coolant level, losing only small amount of coolant stop circulation. Pump driven system is much more robust and can typically handle lower coolant level. Okay guys, this is up to our today's topic, thermosyphon system. Next Sunday we have covered some another chemical engineering topic. Still then do goodbye and do take good care of yourself.